Many times, an engineering job will require translating mathematical solutions into code. Often, interviewers will ask a math-related question to see if you have these skills. Let's look at a problem where you probably know the math side, but need to watch out for tricky details during programming. This is AlgoDaily. This is a problem that you probably wouldn't expect to come up often, but you actually see it quite frequently in interviews, and I'm not sure why. I think it's because it tests a little bit of math, but it tests just enough math that you can demonstrate a strong ability to take a mathematical induction or intuition and convert it into programming. And I think that's what makes this interview question so popular. But in any case, the question usually goes in the form of, given an integer num or n or whatever the input is, write a method to determine if it's a power of 3. And in this case, the problem that we're about to cover, it's testing if it's a power of 3, but in other cases, it'll test if it's a power of 2, a power of 4, or it could be any number. There are so many ways to solve this problem, and I'm going to catch a lot of flack for this, but I think that the best way to do it is to give them a more programmatic answer, because if you're interviewing for a software engineering role, that's probably what they want to see, is your ability to solve this with basic loops and conditions and translate some math into a programmatic formula and a working program. Cover it. Here we see 3 to the power of 6. If you go back far enough in your middle school and high school math classes, you might recall that 3 to the 6th power just means that we are multiplying 3 times 3 exactly 6 times. What this symbol on top actually means is 3 times 3 times 3 times 3 times 3 times 3. And the output of this is 729, and the use of power and exponents is an easy way for us to represent this whole piece without requiring too much space. So 3 to the 6th power just means we're multiplying 3 by each other 6 times. Now, given that 3 to the 6th power means this, checking if a number is a power of 3 means that we can take the inverse. So 3 to the 6th power is 729, and 3 times 3 times 3 times 3 times 3 times 3 is 729. So if we're given 729, how do we know if it's a power of 3? We can simply reverse the direction. If we have 729, we can take 729 and divide it once, thus getting rid of one of these 3's. And then we would have 3 to the 5th power. But if we divide again, we can then remove the 5th 3. And if we keep dividing at each step, we'll eventually get to 1. Because 3 divided by 3 is 1. If we eventually get to 1, we know that it's been divisible all along, thus a power of 3. Now, in writing the code for this, we have to understand a few important concepts first. So when we divide 3 by 3, we get 1. In this case, 1 is the quotient. So 1 is the quantity produced by the division of two numbers. As we come up with the code to do this, we understand that we're constantly dividing by 3 until we get 1. And so we're essentially taking the input, dividing it by 3, but we're then dividing the quotient by 3. We're no longer dividing the original input by 3. We're going to keep on dividing the quotient by 3 so that we could keep shrinking it down. So note that 1 is a valid answer, as 3 to the 0 power is an edge case to be careful of. But the main idea is still to recursively divide by 3 and check that the remainder is 0 and reapply it to the quotient. So here's a lovely diagram that illustrates the pseudocode for this problem. So we'll have a function that takes a number and we'll assign a current quotient to that number. Now current quotient is going to change. So if current quotient equals 1, then we know that this number is a power of 3 because we've been able to divide all the way down to get 1. Otherwise, and in most cases, this is greater. So let's say num was 729. Otherwise, we'll fall into this conditional. And while the current quotient, in this case 729, is greater than 0, we just divide by 3. And 729 divided by 3 is 243. So we assign 243 back to current quotient. And if current quotient equals 1, which 243 does not equal 1, then we continue in the while loop. And we continue because current quotient is still greater than 0, and we continue processing. Eventually, we'll get down to 1, and we'll get into this conditional. And the current quotient, if 1 equals 1, is true. Then we know it's a power of 3. And we can take a look at the code here. Just exactly as the pseudocode had laid out, we take an input number, we assign it to current quotient. If current quotient equals 1, then we know it's a power of 3. Otherwise, we use the reassigning of current quotient to continuously divide by 3. And if we ever get to a point where we get 1, it's true. However, if we finish the while loop and the number is 0, we can return false because we know that it's not a power of 3. Because a power of 3 would have gotten down to 1 at some point.